You ever wonder how your email inbox just knows what's junk? It feels like magic, right? Well, today we're going to dive into the really powerful, and actually centuries-old, idea that makes it all possible. All right, let's get right into it. It really does seem like magic, doesn't it? An email pops up and boom, your inbox just decides, is this important or is it spam? But the core idea behind how it does that, it's surprisingly old.
Yep, that's right. The answer actually comes from an 18th century mathematician named Thomas Bayes. And what he did was he basically created a mathematical way to do something we all do intuitively, which is just updating our beliefs whenever we get new information.
So to really wrap our heads around this big machine learning concept, let's start with something superhuman. Just think about it for a second. Imagine a little kid learning the word ball. They see all sorts of objects, right? Different shapes, sizes, colors. And every time a parent points and says, hey, that is a ball, that positive example helps their internal concept of ball get a little sharper, a little more accurate. And this part is really key. I mean, sure, a parent might occasionally say, nope, that's not a ball, but it's that constant reinforcement with the positive examples that really builds the idea in their head. And that whole process, refining an idea by feeding it more and more examples, that is the absolute foundation of how Bayesian learning works for machines. Okay, so how do we take this really intuitive idea and turn it into something a computer can use, like a mathematical framework? Well, it really just breaks down into three key parts. First up, we have the prior, and you can just think of this as your starting belief, your baseline knowledge. So for example, you might know from looking at medical data that the chance of any random person having a specific type of cancer is, say, only 0.5%. That's your prior belief. It's what you know before you get any new information, like a test result. Next, we've got the likelihood. This is all about the power of your new evidence. It asks a simple question. How likely is it that you'd see this specific data, like, say, a positive test result, if your initial idea was actually true? And finally, there's the posterior. Now, this is the really crucial part. This is the output. It's your new, updated belief after you've combined your starting knowledge with the strength of the new evidence you just got. It's your final answer for now. And here it is, the whole idea in one simple little formula. Your new, updated belief, that's the posterior, is basically proportional to your starting belief multiplied by the strength of your new evidence. Simple, right? But so powerful. Okay, I know this might all seem a bit abstract, so let's use a really powerful real-world example that shows just how surprisingly counterintuitive and how important this whole idea really is. So, let's imagine a screening test for a specific type of cancer. Now, the prior probability, remember that? The chance of someone in the general population having this cancer is super low, just 0.5%. But the test itself, it's really accurate. It correctly identifies cancer 98% of the time for people who actually have it. Okay, so here's the question. A patient tests positive with a test that's 98% accurate. What do you think the probability is that they actually have the disease? Just take a guess in your head. Now, your gut feeling, based on that 98% accuracy number, is probably screaming, 98%. And yeah, that feels logical, right? But that is not the whole story. The actual probability is less than 20%. And this is what so brilliantly illustrates the power of thinking like a Bayesian. It forces us to look beyond just that one piece of new evidence. So, what gives? Why the huge difference? Well, it's because that starting belief, our prior, has a massive impact on the final result. Since the cancer is just so incredibly rare to begin with, it's actually far more likely that a positive test is a false alarm from the huge pool of healthy people than it is a true positive from the tiny group who are actually sick. This is a classic mental trap, by the way. It's called base rate neglect, and thinking like a Bayesian is the perfect way to avoid it. All right, so let's bring this back from medical tests to your inbox. Let's see how this powerful idea gets built into a practical tool we all use constantly, something called the naive Bayes classifier. This is the algorithm that powers a ton of spam filters, and it's called naive for a funny reason. It makes a really big but useful simplification. It pretends that every word in an email, words like lottery, winner, and free, are all completely independent of each other. Now, of course, we know that's not true in real language, right? Words are connected. But making this naive assumption is a brilliant shortcut that makes the calculations incredibly fast.
And that trade-off is what makes it so incredibly efficient. It's simple, it's fast, and it handles messy, real-world data surprisingly well, even though its core assumption is, well, a bit of a stretch. And that's exactly what makes it perfect for those massive, high-volume tasks, like sorting through millions of emails every single second. And that incredible efficiency is why it powers so many things we bump into every day. I'm talking about everything from filtering that junk mail and categorizing news articles to powering the recommender systems on shopping sites that tell you what you might like, and even analyzing customer sentiment on social media. So, when you boil it all down, what's the big takeaway here? Why does this idea from the 1700s still matter so much today? It's because this is so much more than just a tool for machines. It's a really powerful mental model for us, for people. It gives us a clear, logical framework for updating our own beliefs. Whether you're a doctor trying to make sense of a test result, or you're just trying to decide if that email in your inbox is actually worth opening. You see, by formally combining what we already know with what we're learning, this really elegant idea gives us a remarkably effective way to make sense of things, to make better predictions, and just to classify information in this complex modern world we live in. So the next time you're faced with some surprising new piece of information, just stop for a second and ask yourself, what did I believe before this? What was my prior? By thinking like a Bayesian, you really start to see the world a little more clearly. You can avoid those common errors in judgment and just make better sense of all the uncertainty out there.